This video is to explain how to take an equation and create a graph, and to discuss some of the properties of an equation in the form y equals mx plus b. So we already know that the m in this equation represents the slope and the b represents the y-intercept. So we're going to take that information and graph the lines that have been provided. The first thing we're going to do is graph this first line. This first line has a b value of -1. So the b value tells us the y-intercept. So we go on our axis over here, label our x and y-axis. So if the y-intercept is -1, it means we go on this y-axis and put a dot down here at -1. The second part of this equation that we care about is the m value, the number that's attached to the x, and an m value of 3. We like to write that, instead of just as m equals 3, as a fraction. And if you would like to write a number as a fraction and have it still equal 3, you would write 3 over 1. When we write it in this way, it's very easy to see that the rise is 3 and the run is 1. So we start with this y-intercept, and we make a rise of 3. So from that point we go up 3, and a run of 1. So we go over 1 and put a second dot, which we can then combine the two dots with a straight line. And we're also going to label that as y equals 3x minus 1. Now we're going to follow the same steps for our second equation. We start with the y-intercept of plus 2. Y-intercept of plus 2 means start at the origin and go up 2. So y-intercept again means where does it cross the y-axis. And if we look at this equation, the b value is also 3, so it's the same exact slope. So a rise of 3, 1, 2, 3, and a run of 1. And then we can draw our second line in there. So we get y equals 3x plus 2. Question number 2 here asks what is the slope of each of the lines, and in both cases our m value was 3, so our slope was 3. And what do you notice about the slopes of each pair of lines? Well, for this pair of lines, obviously the two slopes are exactly the same. You can see that in the equation, and you can see that by just looking at the lines that the two slopes are the same. We're going to follow these exact same steps to graph y equals -2x plus 1. So again, we start with the y-intercept of plus 1. We can do this a little bit quicker now that we see the method. We start at the origin, and we go up 1 and put a dot. And then we use our m value of -2, which we prefer to write as a fraction. So we will write it as -2 over 1. So from this dot, we go down 2, so a rise of -2 and a run of 1. Put a second dot. 2 dots are enough to graph a line. So we draw our line in and label it. Y equals -2x plus 1. We have one last line to graph. Y-intercept of -3. Start at the origin, go down 1, 2, 3. Graph our slope, which is identical to part A. So slope of -2 is a rise of -2 and a run of 1. Get our second point, draw in our line, label it with its equation, y equals -2x minus 3. And now we have our second two equations. So again, for number 5, what is the slope of the two lines? They both share a slope of -2. What do you notice about the slopes, both in the graph and in the equation? They are the same as each other. And what word best describes each pair of lines? Well, if we look at the first two lines, the purple and the blue, and then we look at the green and the orange, we notice that each pair of lines have the exact same slope, and the way that looks in the graph is that they are parallel. What do you notice about the y-intercepts of each line? Well, if we look at the y-intercepts, I'll circle them here. So if we look at this y-intercept, oh dear. If you look at this y-intercept and this y-intercept, they are not the same, and this one, they are not the same as each other. So the y-intercepts are different, but the slopes are the same, so they look parallel. The y-intercepts don't matter when we're talking about parallel lines.